So here we go, the higher level for the equilibrium topic. Ping An, if you're watching this, switch off now. Now we'll build upon, to start with, stuff you've done already, simply writing expressions for Kc and plugging numbers in and getting a value for Kc and the units. So all I want you to do to start with is write an expression for Kc for that equation that's shown there, and then plug the numbers in and check that you get the right answer. I've got 1.84, as you can read as well as I can, with no units. So pause the presentation and make sure you can get that answer, please. Unfortunately, not all of the calculations are as straightforward as that. And what you're often given is the starting amount of certain materials and then the equilibrium amount of one substance. Remember, if you're just given an amount in moles, you have to divide it by the concentration to get moles per, by the volume to get moles per decimeter cubed. In this example, you've got no volume, and that's because volume is unimportant in this calculation because the volumes actually would all cancel out. 200 grams and 7 grams of water have to be converted to moles first. Now here's how we set up these calculations. We set up a little table. You don't have to draw the lines, that's not a requirement, but what I want you to do is work out A and B and then work out X and see if you can work out the other numbers in this row. And there we are. There's the question. In this case, why don't we need to convert moles to concentrations? So pause the video now and see how you get on with that. The key is the bottom line, that equilibrium amount. And once you've calculated those, you can just plug them into the Kc equation and do the maths. So have a look. How did you get on? Do you agree with my figures? Now what you then have to do, if you agree with all my figures along here and along there, if you get 0.025 more moles of this, then you must get 0.025 more moles of ethanol. And that also means, because it's a one-to-one reaction, the amount of these two substances, that and that, must have decreased by the same amount that that has increased. Okay, that amount is simply from the question. So to work out the equilibrium amount, you just do the maths. That minus that, that minus that. It doesn't take a genius to then work out those two. So then write your expression for Kc, plug the equilibrium numbers in, and you should get 0.22. No units, because you've got the same number of moles on each side of the equation. Okay, I'd work now through the remaining examples in the presentation. You don't need to worry about the video, just go onto the presentation, look through the examples, the remaining examples. Don't go onto the delta G section, the Gibbs free energy part. Please just work out the Kc calculations. If you don't get the answer that I get, please share your solution with me and I will have a look to see where you have gone wrong. I'll be popping a worksheet to do with these calculations on together with this video. I'll try and make sure that I don't put the answers up in error this time.